Hello guys, in this video I am going to tell you how you can write the nodal equation for this particular circuit. And this particular circuit, it is taken from engineering circuit analysis book by Hayt, Kemmerly, and it is question number 50 of chapter 7. So over here we need to write the nodal equation, and the problem is that we have the capacitor as well as the inductor in the circuit. Now whenever we have this type of the elements in the circuit, then is again like we need to write the nodal equation exactly in the same way as we did for the circuit having only the resistors. The only difference is that we should know that what is the equation, what is the expression to determine the current and the voltage across the capacitor as well as for the inductor. So as per our knowledge that we know that for the inductor, our VL, like the voltage across the inductor, it is expressed as L DIL by dt. VL is the voltage across the inductor, IL is the current flowing through the inductor, and similarly the current IL, it is expressed as, like, we need to take the integration of this. So after taking the integration, we will get the expression for IL as I divided by L integration starting from t0 till t dash VL t dt plus IL t naught. Now this IL t naught, this expression, it is the initial current flowing through the inductor at time t equals to t naught, and after that, after t naught, from t naught to t dash, the current that is flowing, it is we are integrating the voltage from t equals to 0 to t dash to get the current at t equals to t dash, right? So these are the expression for the voltage for the inductor. Now similarly for the capacitor, if we look at the capacitor, then for the capacitor, the current flowing through the capacitor, it is given as C dV by dt, whereas the expression for the voltage is, it is again the integration of this, we will get the integration as 1 by C integration from t0 till t dash and ICT dt plus VCT naught. And again this VCT naught, similar to ILT naught, it is the initial voltage that is there across the capacitor at time t equals to t naught, right? And this expression is integrating the current from time t equals to t naught to t dash, so that we get the voltage at t dash, right? So using these expressions for the inductor and the capacitor, we can simply write the nodal equation. So if we come back to this particular circuit, we know that the nodal, like how we write the nodal expressions, right? We know that the nodal expressions for the nodal equations, what we need to do, first step is to identify the nodes. Now over here, the first node will be this one, A. This will be our second node, B. This will be our third node, C. Now over here we also put this as one node, D, because whenever we have an inductor or the capacitor, then the junction between the two elements, out of which one element, if one element is inductor or capacitor, then it is always better to take it as a node, right? And the fifth one is this E. Now this is E is considered as reference node, so VE will be 0 volt. Now it means we need to write a KCL for this 4 nodes, A, B, C and D. Now over here, if we look at these two, A and D, now A and D are forming a super node. So super node is formed between A and D. So it means that we need to write the KCL for these two nodes together. How? Over here, the first let this current, let it be I1, right? Let it be I1. So if this is I1, let me redraw this circuit, or let me zoom it so that like it will be clear, right? Just a minute. Yes, now it is okay. And for this, just a minute. For this, let me zoom it again. So over here, or let me write it again. Okay, so over here you can see that if I look at this, over here it is, let it be I1. So considering this A node, super node A and D, so over here, just a minute, so these are the super node. Like, so first let me write I1, then second current, let it be I2, so plus I2, and then after this, now we will move to this D node, and over here only one branch is there, which is this, let this is I3, so plus I3. So since A and D are forming a super node, so we will write expression like I1 plus I2 plus I3 equal to 0, right? Because this is a concept of super node. And if you have any doubt with respect to super node, so you can go to my lecture where I have solved few examples related to super node, right? So over here I1, I2, I3, and now I1. What is I1? I1 can be expressed as VA minus VB upon 50. Now I2. Now I2 is the current. The direction of I2 is in the opposite direction to this. So it means this I2 will be minus 20 e power minus 20 t. Remember, it is in milli, so I will put it as into 10 power minus 3. Now coming to I3. Now I3 is the current that is flowing through this. Now what is the voltage? What is the voltage across this? Now the voltage across this, it will be VD minus VC. The voltage across the inductor, it will be VD minus VC. Why? Because over here we have a D node, over here it is C node, and since the current is flowing from D to C, so the voltage across this 50 millihenry, it will be VD minus VC. So considering this and going to this expression that we have written over here, this one, right? Because we need to determine I3, which is the current flowing through the inductor. So writing this, what we are going to do, I am going to write expression as 1 upon, now 1 upon L. L is 50 into 10 power minus 3, right? Now integration from T naught to T dash, right? VLT. Now VLT is VD minus VC. So it is VD minus VC dt plus ILT naught. Now ILT naught equal to 0. So this is our equation that we got from the super node AD. Now over here, like the question says that assume no energy is stored at t equals to 0. Now it means no energy means that at t equals to 0, the current at t equals to 0, IL will be equal to 0. Right? So considering this, what we can do, we will equate it to 0, right? It will become 0, and this T naught, it will be 0. So we are going to rewrite this expression, or simply or let me write it as VA minus VB upon 50 minus 20 into 10 power minus 3, so it will be 0.02 e power minus 20 t plus 50, and this is the 10 power minus 3. So 10 power minus 3 can be taken to numerator, so it will become 1000, right? It will become 1000, and then the 1000 upon 50, so it will be 20. So 20 integration, and this will be t dash, this will be 0, vd minus vc dt is equals to 0, right? This expression, it will become 0. So it is our first equation that we get, and this is the first nodal equation. You can see that all the terms like va, vb, vc, it is vd, right? It is vd. So this, all these terms, vd and then vc, all these terms are the node voltages, right? Now along with this, because we have supernode ad, so for the supernode we also know that considering this a and d, we can write that because it is given in the over here, it is given that the voltage of this voltage source, dependent voltage source, is 0.2 vx. So it means that since it is d, so it means vd, minus va is equals to 0.2 vx, right? Why I take vd minus va? Because plus terminal, it is near to d, it is near to d terminal. Now what is vx? Now vx, it is va minus vb. Why va minus vb? Why not vb minus va? Because again plus terminal is near to a, so vx is equals to vb minus va minus vb. Substituting va value of this vx in this, we will get vd minus va equals to 0.2 va minus 0.2 vb, and arranging them, we will get 1.2 va minus 0.2 vb minus vd, it is equals to 0. So this is our second equation, and again you can see that all the variables va, vb and vd, they are the node voltages. So this is another nodal equation, right? Now coming to the third one, remember over here we have 5 nodes. In this question we have 5 nodes, a, b, c, d and e. E is the reference node, so the voltage is 0, and it means that we need to have 4 nodal equations to solve the circuit, right? We do not need to solve the circuit as per the question, so but we need to write 4 equations. So already using the considering the supernode, we have written this 2 equations, right? Equation 1, equation 2. Now let's come to the another node. Let's consider node b. Now considering node b, for node b, or KCL at node b. Now if I redraw this circuit, let me remove this and let me for node b. Now for node b, you can see one resistance is this is c, this is b, this is 100. One is this, it is 50 a, and we have one capacitor over here which is connected to E node, right? Now considering this, we can like have 3 currents, I1, I2, I3, right? The value of the capacitor is 1 microfarad. So our KCL at B, it will be again I1 plus I2 plus I3, right? Now I1, it will be, it is from B to C, so VB minus VC upon 100. Then I2, it is from B to A, so it will be VB minus VA upon 50. And then VC. Now VC, for the VC, it is the current. Well, we need to determine the current, right? And we know for the capacitor, current is expressed as IC dV by dt, right? It is the voltage across the capacitor. Now what is the voltage across the capacitor? Now the voltage across the capacitor, if I look for this, so this is VC. Now what is VC? VC will be equals to VB minus VB minus VE, not VE minus VB. Why VB minus VE? Because the positive terminal is connected near to the B terminal. So VE is 0, this is 0. So it means VC is equals to VB. So it means our IC or simply I3, it will be equals to C dVB upon dt, right? So substituting this value over here, we in the expression we get C dVB by dt, right? Over here the value of C, it is 1 microfarad, yani 1 microfarad means 10 power minus 6 farad, right? So in place of this I will put 10 power minus 6, right? And it is equals to 0. So this is our third equation, right? Now coming to the fourth one, means now coming to the node C. Now considering the node C, if I again redraw the for node C, it is like now over here for the node C, if you look at node C, we do not need to write anything. Why? Because node C is connected to a voltage source, right? And it means that if this voltage source, let it be Vs, so this Vs will be equals to Vc minus Ve, right? Ve is 0, this E, it is a reference node, so it means that Vs is equals to Vc, or in other words, Vc is equals to Vs, which is equals to this 40 e power minus 20 t volt. So our fourth equation will be this. It is Vc equals to 40 e power 20 t volt. This is our fourth equation, which we get directly. We do not need to solve anything for this. So now you can see, now we have the four equations, equation 4, 3, 2 and 1, and all these equations are in terms of the node voltages VA, VB, VC, VD, right? So this is the solution to this particular problem. So if you have any doubt, you can put it in a chat box, in the comment box. Do subscribe my channel and share this video with your friends and colleagues. Thank you.